In this video, we'll be discussing the Mach3Mill software layout and how to navigate between the different tabs located above in the program as well. When you first start the software, this is going to be the main screen we'll be using for a majority of the semester. You may have noticed that the reset button here is flashing. That is perfectly normal when you start the software. To get rid of it, you can either click on it or use the hotkey tilde to deactivate it. You will know when it's deactivated when there's a solid green barrier around it. Right above that, this is where we can manipulate any G-code or upload G-code as needed. And to upload your G-code, you can go ahead and click Load G-code. You can then go ahead and locate your G-code. I'll go ahead and upload an example. Once you upload a code, it will then upload into this window here and quickly run through it to see if there are any errors. If there are any errors detected, you will be notified in the status bar what the error is. And if there are any errors, you can go ahead and click the Edit G-code. It will then open your G-code in a notepad where you can then make any edits as you need. Once you're done, you can go ahead and close out the window. And then Mach3 will reload the code into the window here and again run through it to see if the mistake has been made. Once you upload your G-code in this box over here, it will generate the tool path based on what you have for your G-code. And if you do make any edits, but you don't think they got put into here, you can go ahead and click Regen Toolpath. If you want to navigate in this window, you can use your mouse to navigate. When you right click, you will be rotating at the point of origin where you clicked. If you scroll, then you'll be able to zoom in and out of your workpiece. If you right click, you should be able to shift without rotating at a certain point. And if you need to recenter, go ahead and click Regen Toolpath again. This display bar has two functions. This first function we're looking at is just looking at the G-code and your toolpath. When you click display mode again, it will display an outline of where the machine is allowed to work in and is not allowed to cross over. When you have jog follow on, you will know when it's on when you have the LED lit. It will just basically follow the jog of the spindle as it goes through each toolpath function. If we go over here in tool information, this will display the information about the tool that you are using. If a tool change is required, then this light will be flashing. We will discuss more about tool offsets in a later video. Feed rate is basically talking about how much material is being fed into the tool. You can override the FRO rate by adjusting this green bar here. Two ways to do that is by clicking on it and dragging it, or using these arrow keys to make adjustments. You will notice that once you made the adjustments for the override, this override ribbon will start flashing. To reset back to 100, just go ahead and click this reset button. For the spindle, you can control the spindle speed. In order to do that, you need to click in this box, enter your value of, say, 700 RPM. It will then propagate up to here. And then when you click spindle speed, it will then show the actual speed of your spindle here. Again, to adjust the speed override, just go ahead and click on this bar, adjust it as necessary, or you can use these arrow keys as well. And again, to reset it back to 100, just go ahead and click this reset. Up here is our coordinate system for our machine. It has two separate coordinates. The coordinate system we're seeing right now is the reference or offset coordinates. And this is what we'll be using for a majority of our work for when we're setting our tool offsets and our workpiece offsets, which will be explained in later videos. There is the machine coordinates, which basically tells the machine this is where you are in space, and it works in tandem with the soft limits. Basically, the soft limits is an additional layer of safety. It acts like a digital limit switch, and it works in tandem with machine coordinates. Once the machine coordinates get to a certain point and it hits the soft limit, it will then disengage the movement of that axis and then warn you that you exceed soft limits. And then in order to deactivate that, you just have to move the machine back into soft limits. An important thing to note for the axis for our machine, if this was the front of our machine and this was our wax blocks, our Y positive will be going in this direction, our X positive will be going in this direction, and the Z will be up, or for this case, it will be coming out of the page. Another thing to note is this go to zero function. It basically will move the machine to 0 coordinates using the reference coordinates. It's a good way to check to see if your reference point on your wax block is 0 and where it should be. There's also this reference all home, which will move all the axes back to their home position. By clicking it, it will move the axes back to their home. And once they reach their home, these green boxes will light up, indicating that this is the home for these axes. In order to move these axes, we do have hotkeys set for them. For the x-axis, to move the axis positive, you want to use the right arrow key. To move in the negative x direction, you want to use the left arrow key. To move the y-axis positive, you want to use the up arrow key. And to move in the negative, use the down arrow key. For the z-axis, it depends on the type of keyboard you are using. It will probably be the up page or down page on your keyboard, or the W and S key for your axis. If it's the W and S, the W will be the positive Z, and the S will be the negative Z. Up page will be for positive Z, and down page will be for negative Z. If the hotkeys are not working, then we are able to use actual hard buttons to move the axis. To access that, you can go ahead and click the Tab key, and it will pop up this window where you can then control the jog rate of your axis to just at this, say 5%, and it will move at 5% of the speed indicated in the FOB here. As I also stated, that they're also providing hard buttons to move the axis. So as you can see, I can move the z-axis positive by pushing this, and move the x-axis in positive direction by pushing this button here. In order to get rid of this window, just go ahead and click the tab button again, and it will give you back the default screen. Another important feature to note is these buttons down here. If you are confused about any G-code references while running this machine, you can go ahead and click this, and it will pop up a summary of all G-code that one will be using for these machines, and it provides a brief description and examples of how to use them in a code. There is also the same thing for M codes, which basically controls spindles and tool changes and various other programs as well. So if you ever get confused or lost or want to know more about G-code, feel free to use these tabs to learn more about G-code. The next tab we'll be talking about will be the MDI tab, or Manual Data Input tab. This is basically where you can manually input G-codes. To do that, you can just simply highlight this box until the cursor shows up, and you can type in G-code manually. Like, say you want to move the x-axis a certain amount, you can go ahead and type G0 X1, and it will move it to the designated spot that you commanded it to do. It also has this neat feature where you can create G files by simply doing start teach. When you start teach, this LED will light up, and it will start remembering all the G code lines that you type into this input. And when you do stop teach, it will then create that G code file and upload it to the Mach3 software. Again, most of these buttons are pretty similar to what we had for program run, like the reference all home and machine coordinates, and has some control of the spindle and feed rate as well. The next tab will be the toolpath tab, and basically this is where we can go to verify if our G code will work, and it also provides a bigger window to view our toolpath, and it may sometimes appear like this, but you can simply just zoom in until you can clearly see your toolpath. And again, this dotted line here shows the soft limits of the machine and where it's not allowed to go past this point. Again, if it's like this and just go ahead and use your scroll wheel to zoom in until you can see your toolpath more clearly. But other than that, with the sample G code, we are able to run a simulation program to determine if things are working, and it can also provide us an estimated program runtime. And for the sample G code, it will be approximately 4 minutes. If there were any errors to occur, again, it would pop up down here stating what the error is. And again, in program run, there is the button edit G code where you can make the edits. But say if we are having an issue and we don't know exactly where it is, we can use this rewind button and it will go back one line of code and you can start troubleshooting from there. There is also the ability to run the code in reverse, but I do not recommend ever doing that with our type of code for the semester. But if everything is working fine, you can also click cycle start, which does the same thing as just starting the G code from where it is. There's a similar button on program run as well. Next would be our offsets tab, and this is where we would set our tool offsets and our workpiece offsets. We will be using this page more in upcoming videos. The next tab is the settings tab, and we will not be messing with anything in here. The only thing we need to make sure that is on is the auto limit override, which I'll be explaining in just a little bit. The next tab will be the diagnostics tab. This is basically where we can go to diagnose any issues that we may come across, like these limit switches over here. If a limit switch is triggered, then the LED corresponding to that limit switch will light up, indicating that this limit here for this axis was triggered, and it will also trigger this reset to engage as well. And if the external e-stop was also engaged, then this light will come on as well, but instead of a solid light, it will be blinking, indicating that it is an emergency and also will be engaged in this as well. Same thing will happen if the door sensor is lifted. However, if a limit switch was triggered, you will not be able to reset the reset button here. It will keep on flashing green and red. And the only way to disengage that is to go into the settings and discontinue that signal input and then move the axis off and then re-engage that signal. However, as I stated in the settings tab, if we have this auto limit override setting on, it will allow us to hit the reset and then move the axis off that limit switch. But again, if it's not, then we have to go through the long route of turning off the signal, moving it, and then returning on the signal. So be sure before you run your G code that the auto limit override is engaged. And with that, that is the overview for Mach 3. Thank you for watching.